for you, but there's a link here, and I'll if you if you keep that link, you can have this talk. You can just pull it up on the computer. It'll be in a PDF format. So I'll give you just a minute. Those of you that can write it down to get it written down here, and then we'll get going. Uh, to start with, I wish I could be there. I don't like this no travel stuff. I enjoy going and meeting people. Uh, Ian mentioned that Grigg Brothers was sold to Brandt Corporation in 2014, and it still has the Grigg label. Everything is labeled Grigg. It's made in the same plant by the same people. It's the same formulas that we've always had. It's just not owned by myself and my brother anymore. It's owned by Brandt. This is a picture of the Brandt factory and or at least all of their offices in Springfield, Illinois, and this is where Jared offices out of. Uh, what I've done with this is I've got the next hour, I've divided it into three partials. We're going to talk a little bit of basic agronomy because I think that's a preference for what we're going to talk about. We're going to talk a little bit. I've been asked to talk about different technologies and different foliar products in the marketplace. We'll do that for a few minutes. And then the last thing I want to talk about a little bit is foliar fertility and give you an introduction to what we're going to talk about tomorrow. And tomorrow's talk will be on plant health and how the foliars can help with your plant health and what that means to you. Uh, so we'll touch on that a little bit as we go too. All right, basic agronomy. You guys have two ways to feed those turfgrass plants. You know, I started as a superintendent in 1968, and we never even thought about foliar technology. It probably wasn't until the early 90s that it even came around. And it wasn't until Grigg Brothers started in 1995 that there was really any companies out there that specialized in foliars. So now you've got two choices. There's a lot of foliars in the marketplace. We'll talk a little bit about those. You can put it in the soil, you can put it in the foliar on the plant. The two basic differences here is when you put it in the soil, it becomes a biological process, and we're going to talk about that first. If you put it on the turfgrass plant, spray it on the plant, that becomes a physical, uh, actually a physical way of getting it into the plant. There's no biological involved in it. It's strictly a physical and chemical way of entry into the plant. So we'll talk a little bit about that. Okay, now that we have two ways to put the fertilizer on, uh, which one do I think is best, foliar or granular? Well, what we've found out uh, is that it's a combination of the two that's best. We've proven that since we started testing at university level in about 2000, and then 14 years between 2000 and 2014 when we sold, we did over 100 tests, and those tests are continuing under Brandt. What we found at all the major turfgrass universities was always the combination is the best quality. And I will show you just briefly some slides on that. So I've already mentioned this, foliar fertilization is a largely biological process and it's subject to environmental conditions. Foliar fertilization, on the other hand, is largely a physical and chemical process, and it avoids challenges in the soil, and we're going to discuss that. Okay, so let's talk about granulars first. Anything that you put on your soil for the plants to take it up is totally dependent on the health of the rhizosphere. So my definition of the rhizosphere is this zone from the bottom of your leaf to the bottom of the root system. It's your root system. That's your rhizosphere. Uh, we'll talk about problems that we face nowadays, primarily with height of cut And, you know, if you have a 2-inch root system, you have a 2-inch rhizosphere. If you have a 1/2 inch root system, you only have a 1/2 inch rhizosphere. And the only nutrients that are going to be taken from the soil to the plant are those that are in that rhizosphere. So once anything you put on the soil gets below that, it's gone. We kind of look at foliars as growing this turf grass from the ground up and not from the ground down like you do with soil-borne fertilizers. So that area there is very rich in microorganisms. There's a lot of carbon in that area. Those roots are giving off an exudate. They're giving off a carbon source that's being fed into the rhizosphere, and they're breaking down any organic matter that's being put in that rhizosphere. I will also mention that there are some products being sold in the marketplace with the express reason that it will help you with the biological fraction in that rhizosphere. And lots of different kind of markets for that. Grigg makes a few. There's lots of other people make them, and Even Spray sells several of them. So that's the air. That's the zone that we're talking about. This picture depicts the exudates that are being given off from the root hair. And if you go back and look at this, you can see how many roots there are and how many root hairs. There's a lot of this exudate that's in the soil in that rhizosphere area. And that is being utilized as a source for the microorganisms to feed on. I call it milk and cookies. If I was a microbe, I'd be in there trying to get my share of it too. So the biological fraction in that soil is responsible not only for organic matter breakdown, but for nutrient cycling. When you put nutrients in the soil and they go into that rhizosphere where the microbes are, the active microbial community converts those soil nutrients into usable forms. But and if they're not in a usable form, they're not going to get into the plant. So only those under optimum soil conditions are going to be free in the soil. Usable forms. That's an important message for you, because in order to be usable, that nutrient, number one, to begin with, has to be soluble. You know, let's talk about calcium. Calcium is not very soluble. So when you put it in your soil, you know, it might be, you might do it for several different reasons, but if it's not soluble, it's not going to get in the plant. Only the solubility products are going to get in the plant. That nutrient has to be in a proper ionic form, okay? And that form is basically a neutral form. The nutrient must be free in the soil, okay? It's got to be unfixed. The soil colloids, and I've got a picture of it here. The soil colloids have all of these negative sites around and on the colloid, and they attract all of the positively charged micronutrients for sure. And most of the other nutrients have positive charges. And what happens then is that nutrient becomes fixed on the soil colloid. And some of them are fixed a lot tighter than others. If it has more than one positive charge, for example, aluminum, calcium, magnesium, calcium as a divalent ion, as is magnesium, and aluminum as a trivalent ion. Those are attached very strongly to that colloid. So what the people who make soil nutrients do is they know that the transfer into the soil nutrients. Thought I had my phone silenced. I'm sorry. I'll set it down here on the floor. The nutrients have to be in the neutral form. So what the manufacturers do is they add a chelating agent to there to take that charge. What chelating agents do, if you look on your bag and it says chelated iron, chelated zinc, chelated manganese, what they've done is they've taken that positive charge off of that ion so that it's neutral, so that the plants can take it up better. And by the way, we do the same thing in the foliars. I'm going to tell you that they need to be neutral also. So once that nutrient is free in the soil, then the movement through the vascular system is controlled by the stomata. When the stomata open and the pressure is reduced inside the vascular bundle, water will move upwards into the plant. And when water moves upwards in the plant, it brings the nutrients in with it. It works like this. Again, here's that rhizosphere down here. Okay. What's happened here is everything you see here that's in black is living microorganisms. This is a Gram stain slide. And you can see that they have actually colonized right on the root here. And the reason they've done that is they want to be first in line to get the milk and cookies or the exudates that are coming off of that root here. So then what happens is the available nutrients are being converted into usable forms. And as the water comes through that zone, it picks up those nutrients and brings them into the plant. Now, turf grass, most of us learned in school, is a monocot. So it has these vascular bundles inside that stem. And inside each one of those little vascular bundles, there is both a xylem and a phloem tissue. And the xylem tissue then picks up that water and the nutrients with it and brings it up into the leaf. And once it's in the leaf, then it's converted into carbohydrates. And if we look at this slide, you see all of these little things with the dots on them are chloroplasts. And those chloroplasts then convert it into carbohydrates, and it's taken back down the phloem tissue into the root system where it's stored in the root system. One of my favorite pictures is something like this. You look at this picture and you see these solar panels, and then underneath it you see the turf grass in the lawn. Well, those solar panels those cells on that solar panel are taking sunlight and converting it into usable energy. And that usable energy is in the form of electricity. Okay, the turf grass plants underneath it there are doing the same thing. If you look at that leaf blade as a solar cell, it's taking the sunlight and converting it into usable energy, but the usable energy is in the form of carbohydrates. And those carbohydrates then are what's stored in the root system. The problem we have in turf nowadays, and again, I started in 1968. So if you look on the left side of this picture, I used to mow my greens actually above 1/4 inch. I remember the days in 1968 when we were mowing at 5/16. We had really good root systems. Ball didn't roll very good. I mean, I don't know what our green speeds were, but they weren't much. I had Toronto C15 greens, and we began to lower them in order to increase green speed because that's what our customers wanted. And as we come down, I kept being afraid that I was going to lose my turf. I come down to 1/4, I come down to 3/16, I come down to 5/32. And when I got down to 5/32, then I started having problems with my C15. That's Toronto. And so what we had to do is we had to convert grasses. We had to convert to a newer variety because the new varieties of bent grass have much more leaf surface. Actually, they have more leaf blades. They might not have more leaf surface because what's happened is the newer ones are more dense. So the turfgrass breeders started replacing leaf blades with density. So, now we're down here on the right end, we're down here at 1/4 inch. And what's happened is we don't have much leaf surface there anymore to produce much carbohydrates. So the root systems are not getting the storage in the root system. That's one of the major problems we have. So the two most important factors in how much photosynthesis that plant is using to produce carbohydrates is dependent on a lot of things, but the two main ones are leaf surface. And we keep bringing our green heights down. I mean, I think 1/8 is probably average as I go around the country. That's 0.125. I know guys that are at 1/10 of an inch now. I know guys that are below that now. So if you don't have the leaf surface, what else can you do? Well, you can increase the chlorophyll content in the leaf itself, okay? Because the more chlorophyll content that's in that leaf, the more it's going to provide carbohydrates. Well, how that comes into play is we've got carbohydrates. Well, there's actually 17 nutrients that that plant needs to be healthy and to produce carbohydrates. Carbon, hydrogen, oxygen are being supplied by carbon dioxide in the atmosphere and from water. So the other 14 nutrients we need to manage and we need to give it. And you see these that I've got over here: nitrogen, iron, manganese, zinc, phosphorus, manganese, and sulfur. Those are the chlorophyll builders. Those are extremely important in building chlorophyll in the turfgrass leaf. So if you're combining, and not always is the plant going to be able to get those from the soil. Nitrogen is not usually a problem, okay? Now, you're going to give your plants plenty of nitrogen. Sulfur is not really a problem because most of the products you use have sulfur in them as a byproduct. The atmosphere has sulfur in it, and when it rains, it brings that sulfur down. So nitrogen and sulfur, we don't worry too awful much about, but the foliar program that you're using needs to make sure that it has iron, manganese, zinc, phosphorus, and magnesium in it. And what we found with phosphorus through a lot of research, and I will mention that again, is that you really, if you've got phosphorus in your foliar program, you probably don't need it in your soil. And that will make the environmentalists very happy to get it out of the soil, because that's how it gets into the environment. So, and I'll show you a little bit of that research we did. So make sure that your foliars contain iron, manganese, and zinc for sure, probably phosphorus, and all of the Grigg Brothers products do that very well. And our programs do that very well. And I apologize if I say Grigg Brothers. It's not Grigg Brothers anymore. It's Grigg products. So just forgive me if 25 years of being Grigg Brothers, it's just habit. Okay, here again it is. Nitrogen, you're gonna get two ways. You're gonna get the nitrogen from the fertilizer you're putting on your soil, and you're gonna get a little bit that's in your foliar program. The random ones in red here, iron, manganese, zinc, phosphorus, manganese, need to be in your foliar program. You can put them in the soil, and I don't have but an hour, so I can't go into all the biological reasons that those aren't going to get into the plant, but soil pH has a lot to do with it, as does soil moisture, as does a lot of other things. Sulfur, we don't worry too much about because it's already in those products. Okay, here's the way that works. Those nutrients, nitrogen, iron, manganese, zinc, phosphorus, and manganese and sulfur, are the chlorophyll builders, okay? The more chlorophyll that you have in that plant at any given height that you cut it, the more photosynthesis you're going to have. And photosynthesis is what makes carbohydrate production, okay? So the carbohydrate production is what you're after. And the more carbohydrate production you have, then the more that's going to be stored in the roots, and the root growth is going to be greatest when it's getting those carbohydrates. The more root growth you have, the more exudates are going to be given off by the root hairs, which is going to provide for you a healthier rhizosphere. And the healthier your rhizosphere is, then the better uptake of nutrients are from that rhizosphere. One of the things that I have always done, although I never see it in print anywhere, is I look at foliars a little bit like priming a pump. Those foliars are going to give you, those are the chlorophyll builders, and they're going to give you more carbohydrate production, which is going to give you better uptake from the soil. Okay. I did 7 years in college, 4 years at Utah State in agriculture, and 3 years at Michigan State University in agronomy. And one of the things that we learned in college, and that you need to remember, is called the law of the minimum. That was a man by the name of Justus von Liebig, and it was in 1840, okay? what he found was there are 14 essential nutrients, and I think nickel has been added to that now, but I don't have it on here, and it's pretty minute quantities. The problem I have is when I go to education programs, and I was at the Canadian show 2 years ago up at Banff, and one of the USGA agronomists from the United States got up in front of your group of Canadian superintendents and told them all they really needed to grow good turf was urea and iron, nitrogen and iron. Well, for some reason, the USGA, and I don't know about the Canadian equal to that, but a lot of the professors have jumped on this basic bandwagon because they think what the superintendents want to do is save money. Now, I don't agree with that. I think what the superintendents want to do is have healthy turf. And we'll talk about why they want healthy turf. And what Von Liebig found was that the growth and the health of that plant would only reach that nutrient that was the limiting factor, and that one substitute, no element can substitute for the other. Basically, here's what it looks like. If you've got a chain and there's 14 links, and actually there's 17 links in that chain, but there's 14 that you're managing, and you have one weak link, you've got a weak chain. So I don't agree with the educators that get up and tell you that all you need is nitrogen and iron. And I know several of them that are on that kick right now, and I just do not agree with it. I guess because of all the education that I got that told me that I had to have, and I schooled under some pretty knowledgeable people. You need all the essential nutrients to have a healthy plant. Okay. Well, when that plant makes carbohydrates, about half of them need to be stored in the root system, somewhere between 30 to 80%, depends on the variety, are being excreted back into the soil. So part of those carbohydrates are being utilized as an energy source just for the plant to maintain daily activities. And when you get into stress conditions, like in the hot summers and the cold winters, that's taxed. It's probably more than 50%. So products can be also what I've got here as a third bullet point is you can also substitute some other carbohydrates in your soil. You can put them on there and water them into that root zone, and that will help. And there are a lot of products out there in the marketplace that are called milk and cookies. And I think there's something to that. You can feed those microorganisms. We can either make the plants feed them better, or we can also help substitute some. So those microorganisms need the metabolites. Okay. My summary here, what I'm saying is, if you guys are mowing your greens, and it doesn't matter what kind of turf it is, if it's annual bluegrass or if it's bent grass, or it doesn't matter what variety it is, if you're mowing those greens at 1/8 of an inch or less, and most of us are, and it doesn't matter what it is, that turf grass is going to is going to struggle to produce enough carbohydrates to go around. So the carbohydrates that it's producing, number one on their list is survival. So if it's trying to survive, it's just not storing excess carbohydrates into that root system. And if the root system doesn't have the carbohydrates, and it's not going to produce the exudates that the microorganisms need. So bottom line is, your root system is responsible for producing the soil microbial community with a food source, and it is responsible for the health of your soil. So without a healthy root system, you do not have a healthy rhizosphere, in which case you absolutely need foliars. And, all of your different, whoops, something happened there. I didn't mean to click on that. I meant to just click on the slide. So I can make a good case for foliars just to increase that chlorophyll in your plant, and there are other reasons for using it. So we know that a lot of you are using foliars. We know that from talking to people. We know that from surveys. We know that I've got a group, and I noticed some of the names here that are listening to me right now, and I know a lot of you are in my group. So You know that every once in a while the foliar talk comes around. Here's what you guys need to look at when you're looking at a foliar product. Look at those that are science based. Don't look at the ones that tell you they're science based, because they'll all tell you that. Look at the ones that are science based. Look at the ones that have been proven. And how do you prove it? Two ways: by the superintendents that are using it and how much they like it, okay, and how long they've used it and which ones they're using, and also whether it's being used in independent university test data. We'll talk about that for a minute too. Look at the quality of the product. You can actually, in some cases, see the quality right in the jug. Now, with the Grigg products, we put them in clear jugs, and you can see that quality right through the jug. A lot of producers use opaque jugs. There are even some producers that use colored jugs, so you absolutely cannot see what's in the jug. Look at the jug, make sure it's clear, make sure and good quality stuff doesn't say, make sure you shake the bottle before you use it. It should be that way all the time. You should be using products that are compatible, okay? The reason for that is, and it's particularly in my group, and as I go around the world talking to golf course turfgrass managers, they're putting more and more things in the tank. They're mixing, most guys are mixing 8, 9, 10, 12 products in that tank to save labor. They don't want to keep going out and spraying. So make sure that the foliars that you're putting in that tank are compatible with what else is in the tank. The Grigg product line is extremely compatible with everything. And for you to check the other products, if you haven't used them, just do a little jar test. Take the same combination in a jar with the same proportions and shake it up and let it settle out for a little bit and see how it stays in solution. And you also want products that are efficient. Now, efficiency, how do you measure it? There's only one way to measure efficiency, and that's in a laboratory. You put it on the plant and then you check to see how much is in the plant after different periods of time. To my knowledge, Grigg is the only one that has ever done that. I've never run across another product that's ever looked at the efficiency of their products in a laboratory. I'll just tell you where you can find that. Okay. There's lots of foliar out there in the marketplace right now. When we started, we were basically alone. There really wasn't any others out there, although they were being used in agriculture. And that was where we got the idea. My brother was actually selling those products in agriculture and got a hold of me and said, why can't you use these in turf? And he sent me some products, the products that we now sell under the Grigg label. He sent me, and I used them for a year before we ever started selling them to anybody else. So when you look at the different companies that are out there now, and last time I went to a show, which, you can't walk around and look at those products in a virtual thing like we had this year. But there's probably 24 products in a marketplace now that are labeled as foliars. Probably half of those are being made by the same companies and just being sold under different labels. So you probably have a choice of maybe 6 or 8 different products out there, although the labels may differ. And what the difference in those foliar absorbed products is what we call the coordination compounds. It's not the nutrients that's in the jug, it's the other stuff that's in the jug that's put in there to make those useful and to make them go into the plant better. The biggest difference that I see as I go around is that most companies are taking a single coordination product, and I'll just pick on one, let's say humic acid, which isn't the best, but a lot of them use it. Now they put humic acid in the jug, and then they add the nutrients to that, and they add the nutrients, and that's how they make the different products, is that there's different nutrient availability in the product, okay? But all of that coordination is the same product. Every jug has humic acid in it. If it's a soybean oil extract, every jug has soybean oil in it. If it's from the wood pulp industry, and there is good products out there that utilize that, but every jug has the same coordination compound in it. Well, The person who did the Grigg products was a man by the name of Dr. Gene Miller, who is no longer with us. Dr. Gene got his PhD in plant biochemistry and was the head of the botany department at Utah State for a long time. And that's who formulated all of our products. And what Dr. Miller did was he knew that it didn't take the same technology for each nutrient. In other words, in his mind, the best way to make iron available wasn't necessarily the best way to make zinc available. And most companies use the same product. Every product that Grigg makes is a unique product. No two have the same base in them. Every base is different. And it depends on the product and what's in that product is which one. So I don't know any other company out there that makes the products unique. The problem we have with that is that way of producing products is more expensive. And so products are more expensive. And there's a lot of people now that are just looking at price. So it's easy for other companies to come up with lower prices. I talked a little bit about university data. You see these, and I know some of you maybe aren't looking at the screen. We've done all of our research over the last 20 years at the major turfgrass universities like Nebraska, Purdue, Michigan State, Ohio State, Oregon State, and up there in your area, we use Olds Lab. I don't have Olds on here, but we've used Olds at various times also. You know, University of Vermont, Connecticut, Utah State, Tennessee, University of Arizona. Penn State has been big to us. We've been doing these at all these universities for over 20 years. And we run test after test after test. And we look at a lot of different things. I don't know any other company that does that. Is it important? Well, we ask ourselves that question. Back in 2014, when we were at the GIS show, we did a survey. And we only asked 3 questions. Do you rely on university research when you buy products? 5% of the researchers said no, of the superintendents said no. We buy products for other reasons, but we don't look at university research. Well, B, 43% said, yeah, university research is important to me. So I look at university research. Then 53%, and I had hoped it would be higher than that, said it depends on the study. So what that 53% knows is that there's a lot of companies out there that do university research, but they don't do it at the major universities, and it's not independent research. And if they don't get the results they want, they don't publish it. Well, the universities that we deal with publish it whether we do or not. So 53%, or a little better than half of the superintendents, understand that there is quality research out there, and they look at that research. So we're hopeful that you're looking at Grigg research. And by the way, the same person, Dr. Gordon Kaufman, who drove the process at Grigg Brothers, is now with Brandt, and he's still driving that process. The biggest difference is that it's not all Grigg. Brandt makes a lot of products also, so they're doing a lot of research also. Well, here's the bottom line. In those 14 years that we were Grigg Brothers before Brandt bought us, we did over 100 tests. And no matter what university we did them at, we always compared our products to granular. And we always included a mix of both. You know, we always used a combination of foliar granular. We used granular alone, foliar alone, and combination. And in every test for 2 years at every university, it was the combination of the two that provided the best health and the best quality. Now, I'll just show you a couple of these because we don't have much time. Test back at Ohio State. What they tested was they put down 1.7 pounds of nitrogen during the summer. And they put it on granular, they put it on foliar, and foliar had no granular in it at all. And then they used a combination. Well, where they put the granular on, I can show you every place they applied it. They applied it here, Then the quality dropped off. They applied it here, it jumped up. And, and then they applied it right here and it jumped up again. You get that up and down formula every time you put it out. So what we used to do in my old days was we used to use smaller and smaller granulars because we didn't have these tiny ones that they do nowadays. So we'd get better coverage. And then and then along come the slow release, which released those a little slower. But we still got a bit of this up and down motion. Trouble with a foliar is if you're not putting any granular on there, you don't have anything in the soil. And so it begins the season with nothing in the soil as a carryover from spring fertilization or from fall fertilization. So it takes it all through the growing season to continue to get better and better quality and better quality. And you can see here by about August, quality was up to 6.5 or 7. And it was September when it jumped above up into 7.5 and 8. And it was October before it hit the line at a 8. And for whatever reason, Ohio State used 0 to 9 instead of 0 to 10 to get it up to the 8 level, which is where everybody wants to be. It took all summer. But the yellow line here at the top is where they put half the nitrogen in the foliar and half in the granular. And so half of that 1.7 pounds during that season for each. And you can see that line stayed above 7 and approached 8 and was above 9 all the way across, pretty uniform. Well, we got the same thing at Michigan State. And Dr. Nikolai was comparing 1/10 of a pound of foliar every 10 days with 1 pound of granular a month. And he's doing that because I'm telling Dr. Nikolai that foliars are more efficient. So you could probably get by with using a lot less foliar. So what he wanted to do is he's only putting out 3/10 of a pound of foliar as compared to 1 pound of granular. And you would think that would put us at a disadvantage, but it didn't. Quality was the same across the board. Here's what his test showed. 1 pound of N is urea every 30 days. 1 pound of N is methylene urea every 30 days, 1/10 of a pound of foliar, and he used Gary's Green, and 1/10 of a pound of Gary's Green. This was before we had Gary's Green Ultra. 1/10 of a pound of Gary's Green is 6 ounces per 1,000. And then he used it, and that was every 10 days. He used 1/10 of a pound of foliar every 10 days. Plus he went out with a 1/3 rate of Primo. Primo was just coming into the marketplace then, and we were looking at how effective it was. And I'll talk a little bit about that test. I think we should have continued that test on its own. We put some granular on there that had phosphorus in it. It was the grow-in granular and 1/10 of a pound of foliar every 10 days. And then we put 1/10 of a pound of foliar in with 1 pound of granular nitrogen from a 6,2-O source. You should recognize 6,2-O as Milorganite because we wanted an organic in this test, and we didn't have our own organic at the time, but later on we did. And then he had a check with no nitrogen. You can see his plots here. These are the actual plots. What he found was over a 2-year period that 1/10 of a pound of foliar every 10 days with a 1/3 rate of Primo. And the foliar mixed with fertilizer was by far the best quality. So, and it didn't matter if it was the grow-in fertilizer or the organic fertilizer. They both looked good. Dr. Nikolai is the guru of green speed, and he found no difference in green speed in any of these plots. And quality was always best on the combination. Then I went to Dr. Nikolai and said, Dr. Nikolai, I'd like to continue that test over a longer period of time and include other products on it. Dr. Nikolai is working with Dr. Frank and said, well, here's what we'll do. We'll use your money to hire a graduate student to do all this work for us. So they hired a little Chinese student. You see her name on here. I can't pronounce it. Mayan Zhao or something like that, but we called her Nancy. When Nancy left Michigan State, she actually went to Guelph, and I understand that she's now left Guelph and is out in the marketplace working for a company now, but I'm not sure which one. Kevin Frank was involved in this testing, and Dr. Nikolai, and we continued this test for 3 years. Actually, we continued it for 7 years. Nancy did it for 3 years, and then Dr. Nikolai continued it after she left. So we did 7 year study, and we did it on 3 root zones. I don't know anybody that's done that kind of study. Here's a picture of Nancy on her test plots. Uh, she had USGA 80-20. She had USGA 80% sand and 10% uh, peat with a 10% soil, because we wanted to see if soil would hang on. We know that sand loses its nutrition pretty fast. We wanted to see if a little soil would hang on to it longer. And then we used a native soil. This was done at Michigan State University, and that native soil is a sandy clay loam. Okay. Here's her actual test. And you can't read it very well in this format, but I wrote it out this way. She had urea on there, urea with phosphorus again, urea plus potassium, methylene urea as a slow release, natural organic, which now we've used our own product, which is a 10-2-4 all 100% natural organic. She used foliar alone at 2 different rates. We used a high rate and a regular rate. We did foliar plus granular, and then we did an untreated control. Now, besides turf grass quality, we also looked at green speed. Dr. Nikolai does nothing without looking at green speed. We looked at Poa annua differences in the plots. We looked at disease differences and the different kinds of disease differences. So there's a whole lot of information out here, but it's an entire talk on its own. So maybe someday Even Spray will invite me up and we can talk about this one test that we did over 7 years and what we found. But for purposes of today's talk, I'll just tell you this: for 7 years, always the foliar plus granular was the best quality, always, in every test for 7 years on every soil type. Well, where that leads us to is the last of what I said I was going to talk about, is this thing IPM, which is integrated plant management or integrated pest management. I prefer to call it integrated plant management. Here's all the things that go into that. There's lots of arrows here, but the one that I want to point out is plant health. And here's where I think foliar sprays can help the plants. Now, I'm not going to talk much about it today because my time is very short. This is the one that we're going to expand on in the morning. We're going to take this one, plant health, and talk about it tomorrow. So what I will say is that IPM emphasizes the growth of a healthy plant. That plant needs to be healthy. That'll help ward off a lot of problems. We think that there are elicitors that can be added to that foliar program. A lot of those elicitors with the Grigg products are already in the product. Not all of them are that way, but we've already put let's use Gary's Green Ultra as an example. Gary's Green Ultra has an awful lot of kelp in it. So there are other amino acids that we put in some of these products. So the Grigg products already contain some elicitors. Well, there are other specific ones that we can look at that help with specific nutrients. And remember, we talked about those specific nutrients that are important in producing chlorophyll. So obviously those are important to us. Those are the ones we're trying to get into the plant. We know that there are specific amino acids and other organic acids that can go into that formula that will help get those specific nutrients into the plant. That's where the science of this comes in. Okay. We also know that kelp extract can be added. And, here's my opinion on kelp extract. I think kelp extract is God's gift to golf course superintendents. But the only one that really is healthy that we can see research on is Ascophyllum nodosum. And Ascophyllum nodosum, a lot of it is produced over in the eastern part of Canada and over in the Arcadia area. And some of it comes from the North Seas in Ireland and around other areas. That's the one that's helpful to you, and that's the one that we use in our product. And then you can be using phosphites. And when Grigg Brothers started, There wasn't anybody that really was keen on phosphites. And we looked at some of the research in agriculture, and we started doing research on phosphites, and we were really the second product in the marketplace with a phosphite in the turf marketplace. There was one other that beat us to the punch. Now there's a myriad of products. It's become a commodity now, and there's lots of different kinds of phosphites. And tomorrow we will talk about some of those, and I'll show you some of the research that we've done that shows how efficient the PK Plus, which is our phosphite product, how efficient it is when it's mixed with low doses of fungicides. So we'll do that tomorrow. Okay. I'm just going to talk about Turftopia because this is one that the Grigg is now producing. It's the newest one in the Grigg label. And when just before Dr. Miller died, he was playing with this product, and we had a name on it. It was called Elicitor. And what it is it's a mixture of a lot of different kinds of elicitors in one product. And we've got some new research that was just done at Penn State and was just done at Rutgers that shows that the Turftopia, when mixed in both our program and the Brandt program, really helps with the efficiency of the foliar. So I'm guessing if you're using somebody else's foliars, it will help you with that too. But we don't do research with other people's products. We only do research with Grigg and Brandt. So we'll look at that tomorrow. Just let me tell you, when I talk about organic and amino acids, I've had a lot of people ask me the difference. An organic acid contains carbon. That's what makes it organic, is the carbon. And it has this OH and oxygen group on there too, which makes it an acid. But to be an organic acid, it has to have carbon in it. To be a amino acid, it must also contain this nitrogen hydrogen group, which is an NH3 group. So amino acids have a little bit of nitrogen in them, and it's structured a little different. But amino acids are organic acids because it has this carboxylic acid group on there also, but it has the amine group in it too. So amino acids are organic acids, but not all organic acids are amino acids. And so we're utilizing these in our products. And we'll talk quite a bit tomorrow about potassium phosphate. And it's really the only one I'm going to talk about because it's the only one that has any research on it. If it doesn't have research on it, I'm not going to talk about it. There's dipotassium and monopotassium phosphate, and it needs to be potassium phosphate. A lot of the companies now have jumped on the phosphite name, so they're using calcium phosphate, other types of phosphite, so that they can have the phosphite name on their label. So we'll talk about that in the morning. I'll also talk a little bit more about kelp. As I said, it needs to be Ascrophilium nodosum. That's the best kelp. You will see some products that say it has kelp extract in it, but it doesn't say what kelp. I would not utilize those if it doesn't tell you which kelp it is. There are also products in the marketplace that say it has weed extract in it, aquatic weed extract. Well, there's lots of different kind of weeds in the ocean, and not all of them produce an extract that's healthy. So what you're looking for is the best kelp products in the marketplace. I'm just going to leave by telling you that we've done some work with Turftopia. We've done it at, and I don't have this tomorrow, and that's why I'm showing it today, because I just got these slides. This is work that was done at Rutgers University. And basically what it showed is the Grigg program, which is on this slide. It's Gary's Green Ultra with PK Plus added and a low labeled rate of Daconil Ultrex. That program did pretty good on its own. The Brandt program did not have the phosphite in it. It didn't do quite as good. The Grigg plus Turftopia is up here at the best rating. So even better than the Grigg alone was the Grigg with Turftopia. And the Brandt had a product in it called Megalex, which comes from from one of their side companies that they deal with. And it had Megalex in it. So the Brandt products with Megalex did well. It doesn't look as high on the bar, but you see that little A on there. That means statistically there was no difference. And the Daconil Ultrex alone didn't do as well as either one of those. I happen to be a picture guy, So I like pictures. This is a test that was run at Penn State. So this is Dr. Kaminsky's uh, pictures, and you can see the Grigg program with the Turftopia in it did better than the Grigg alone, which is, I don't have it labeled, but it's the one behind it. The urea alone didn't do all that great, and the fungicide alone didn't do as good as the Grigg with Turftopia in it. So we'll talk about that some more tomorrow. My primary goal of using elicitors in these programs is optimum plant health, okay? Especially during periods of environmental stress. One of the new, and it's so new, I don't even have any data to show you yet. I just got it 2 days ago. One of those tests with Turftopia showed that treating the plants going into winter would enhance them quite a bit coming out of winter. So again, that's that environmental stress, okay? We believe in using pesticides correctly, and when we mix low label rate of pesticide, we will never go below the label rate. There's a high label rate and a low label rate, and we use the low label rates. We accomplish this by maintaining complete and balanced nutrition. Complete and balanced nutrition is why we add foliars to the programs, and we also add elicitor technology to that. That enhances the plant's resistance, both abiotic and biotic resistance. And we're going to spend more time talking about plant health in the morning. So my summary, modern foliar technology. We have a lot of studies that show that complex and chelated foliars can get in the leaf quickly. We have a lot of programs that show that it facilitates the availability of nutrients in the plant. And we know this, that once that nutrient's in the plant, it really doesn't matter how it got in the plant. It's in the plant. It's going to be utilized in the plant. Now, Ian, I'm not sure how this works. I understand that you're required, and by the way, at the bottom slide here is where you can get this a PDF copy of this talk. But I understand that you have to give these guys a test now. Is that correct? Ian, are you there?
Yeah, I'm here, Gary. Yeah,
You're going to administer the test yourself?
yeah, we've sent the tests to all the Ontario guys. They just have to fill it out and send the results back to us, and we'll look after it from there.
So are you going to do that right now, or are you sending it
No,
out to them? How are you doing it?
They have them all in their office, so they can do them at their leisure, and go from there.
Okay, well, that'll make it easier for them because they can download my talk.
Yeah.
And actually have my talk right there. It's a simple 10-question test, and we've never done it in the States, but I understand your government now requires that to get credit for this.
That's just
So,
for the province of Ontario.
Ian, I'm right on an hour and I'm done. Is there
Perfect.
anything do you want to allow guys to ask questions now?
We can open it up if anybody wants to. Right at the bottom of your screen should be a chat button. If you want to pose any questions.
They would have to unmute their mic, and then I hope I can hear them. I got Jared here to help me.
Yeah, if anybody puts it in the chat, we can relay that to you.
Also. If nobody has any questions, then I did a really good job today, and you understand everything. And tomorrow we're going to expand on the plant health part of this talk. There was just no way we could do it in an hour.
Hey, Ian, this is Jared.
Yes, sir.
One thing I wanted to update you on, because I know my dad won't do it for himself, but he just passed his 9th consecutive certification at the GCSAA.
Well, congratulations, Gary. That is quite an achievement. You probably wrote some of those questions yourself.
That's 45 years, and I tend to have in my mind that that's enough.
Excellent. Well, if there's no questions of Gary, I mean, we'll be back here tomorrow, 9 o'clock. And thank you all for attending.
Well, thank you for having me.
Thank you, sir.
I'll see everybody in the morning, or at least you'll see me in the morning.
Right.
Thank you. Okay, Jared, I'm out of here.
All right, take care.
Okay.